for people with disabilities or other types of impairments to make their life easier or to improve their access to technology.
All right, so as you heard, we have a fantastic team here from different countries, from different parts of lives, and different experiences. So this panel is about AI, artificial intelligence, and of course, it'd be nice if I were to define what AI is. Like I said, AI is kind of like a concept that is, I think, difficult to grasp, if anything, because it's changed its meaning through the years. So for those who are old as I am, may remember that in old times, artificial intelligence was when we tried to teach computer to reason basically one formal rule at a time. We really wanted to teach everything. That didn't work so well. More recently, I would say that AI has certainly kind of like taken over also the meaning of machine learning, where if I could say what machine learning is in the smallest number of words, I think is teaching computers to do things by examples, by a lot of examples. But also I see that AI is used more in general to mean autonomy. Autonomy has been out there for many, many years, but somehow certainly you can do many more things now, also through computers that learn, let's put it this way. So I will let my panelists to choose whatever definition they want for AI. And I put together a set of questions that I have a cheat sheet here on my phone because I forget. And I'll make sure that there is a lot that could be said here, and then we'll try to touch as many things as possible. But I also want to make sure that there is room after our blabbering here for the public to come in and tell us what you think. So, all right, the first question I have, the elephant in the room, that's privacy, right? Everybody's concerned about privacy nowadays, and rightly so, when we talk about AI. So, and let me try to be a little bit more specific. Privacy comes in multiple, or privacy breach can come in multiple ways. Like I said before, when we talk about AI or machine learning, we talk about learning by examples, learning by what is called training data. We need a lot of training data. That could be pictures, there could be audio. And collecting training data oftentimes is done without a lot of consideration about privacy. So all of a sudden we discovered that the systems have been trained on my pictures, or what I was doing there. I didn't know that you use my face, my voice. I didn't know that somebody at Apple or Amazon, these places, might have heard what I was saying. Other situations in which AI could breach our privacy is when, for example, we have images or speech that is processed in the cloud. I may think, hey, if the system is in my hand, that's where all the computation is done. All right, it's right here. But if my image has been sent to be processed somewhere else, how do I know that these people are not storing it, that somebody else is not looking at that, an example? So, privacy is clearly a big issue for any AI system. But I would say that when we are using that for access technology, for assistive technology, that is a particular vulnerable situation. All right, and let me make a couple of examples. Do you guys remember TapTapSee? In that case, you take a picture that is sent out to the cloud, then either a machine or a person, we don't quite know, is going to analyze that and give us a result. Now, if I don't see where I'm taking a picture because I cannot see, and the picture might have something that is embarrassing, something that is sensitive, something that is private, how confident I am that this information will be secure when I send it to the cloud. These are the typical examples that we may have. You know, if we have systems with microphones and cameras, we never know. But again, if we can even control what is being taken by the camera, I think that puts us into one of those situations. All right, so this was like the background that I wanted to have here, and it's not quite a question. I just want to hear what you guys think about that. This is a seat for discussion. So whoever wants to start first. Actually, I'm going to start maybe from Patrick over there.
Sure. Yeah, thanks, Roberto. Great question. Very interesting premise. Yeah, I think when it comes to machine learning and privacy, I like to take a step back and kind of think about kind of where we see AI and machine learning in computing systems and different products, and it's very pervasive actually. It's almost everywhere. So for instance, like at Google, you type in a search in the search box. We use AI to kind of provide the results. Same thing with maps. Voice typing uses machine learned models that are trained on people's voices. And even, you know, taking a photo with a camera, we use different models to improve the picture after it's taken, to improve sharpness and contrast and things like that. Now, there's kind of this dichotomy or a difference when it comes to where the processing for these systems takes place. And so as Roberto mentioned, like for some of these systems, you take a photo, it might get sent to the cloud, and there's some processing that happens there. And you're kind of relinquishing that data, that image, that voice snippet, and it's going to the cloud. It's leaving your device, your control, and going to some other system. And there's also these types of services and products where that doesn't need to happen. It stays on your device, and there's what we call a model, which is a machine-learned piece of software that takes an input like this image or this voice snippet and then provides a different result. So some of these go to the cloud, some of them stay on the device. And there's a big privacy implication between the difference of these two, right? There's also kind of a performance or a, to some extent, productivity difference. So when something goes into the cloud, there could be lots and lots of machines that provide more beneficial results necessarily than if it's simply running on your device. Like I always am with the point of view that you don't necessarily know actually what's happening if things are leaving your device and going to the cloud with some of these. There could not be even an indication. I think it's really important actually for us as users of this software to be informed about how this works. Try using some of these things with airplane mode on. Try reading the terms and conditions, although that's not always that fun, right? But to some extent, we really have to be our own advocates and really understand kind of how our own data is being used by these systems and services and make decisions kind of that match our own needs, I would say. Any other comments?
So it's interesting because I think everybody in the panel has a lot of similar perspectives, a lot of different perspectives because of the work that we do. So I'll give you an example from WordCamp specifically. When we designed our device, we had to think really hard about making it cloud accessible or make all the computation locally on our device. And the company opted for making all the computation on the device locally. For security reasons. Working with many people who work in sensitive environments that access sensitive document and information, having a device that has access to the cloud was a predicament to our success on one side. On the other side, not having access to the cloud prevents us from having certain abilities that some of our users would like to have. So it's really a give and take situation where a decision has to be made. Having said that, things that are done locally on the device sometimes are done faster because there is no that connectivity issue that depends on the speed of the internet and other factors that may be involved. There is also, that's the benefit. The flip side of it is when the machine learning actually works, you may have less data because it's only based on what you have. So those, when specifically with assistive technology, when we make the decision or the users make the decision what kind of assistive technology they should use, whether it's an app that connects to the cloud or a device that is self-contained. I think it's something that we should always take into consideration if security is something that you care about, especially with OCR, when we read information such as our bank statements, letters from our doctors. Do we expose ourselves potentially to hackers that can get access to our information? Or do we not get access to information because another device may not be available? I think we all need to be educated consumers and think about those things before we decide to buy and use a particular device.
Yes, I mean, I think you guys said most of it, but from our perspective as well, we also, as Patrick said, we're using AI for different, or machine learning for different purposes. Some of them are easier to train or faster to train because you can collect the data easily. In our case, for example, gesture control, or getting information out of the sonar sensor so we can understand better what we are identifying in front of us. But some other things like vision recognition, that thing requires way more data. Specifically, you have to train it for different purposes, because that's the thing you always get. Depending on the solution you want to build, you need to design a specific experimentation. So the thing is here, I think, as they say, it's important that as a consumer we understand, we are very well informed of where is our data going, but also to understand that as a consumer, in the cases that we are open to do it, we should cooperate, because the more information we provide, the better the solution is going to turn out at the end.
Thank you, guys. I think this was great, and it put a lot of interesting issues here. One that was talked about was education, information. It's important to know and understand in which situations we are giving something away. And I think that, and this happens everywhere, we must accept that we give away something in order to get something. And that's the game we play. The important thing is that we play this game informed. And so that's kind of like the difficult part, I think. And especially, also Marco brought up something good here, that it's a double loop here, because by giving away images, sound, etc., we unwillingly contribute to make the system better, very likely, right? Because whoever is at the back end may use that images we're taking to increase the training data set. So there is an advantage, but again, that comes also potentially with loss of privacy. And again, I would say what I learned from this conversation is that the number one thing is education, understanding what you're giving away, and understanding that you are accepting to do that by using these apps and by using this information. Very nice. Now, another issue that people talk about a lot recently is the risk of bias in AI. So you probably read it on the news sometimes that you get some strange results for people with in minorities, and some undesired results at times. And part of the reason may be that because the system need to have a lot of training data to learn, if we do not balance the training data correctly, the system just learns from the majority, not from the minority. And if we are talking about access technology for particular types of communities, for example, people with low vision, people with low hearing, and etc., these are communities that are minorities. And so we need to make sure that the training data that is used for these systems reflect that. Now, this is a little bit abstract. So I'll make a little example here. Like Pat said, in my laboratory at UC Santa Cruz, we with my PhD students, we try to work on technologies, on access technology, and one of these is access to text, right? You guys know, I think, what OCR, optical character recognition applications are, for example, Seeing AI and the like, NFB reader and etc. Now, these types of applications, which are working better and better, they are AI applications. They are trained on a lot of data, on a lot of images of text. However, if I, as a sighted person, take an image of text, most likely I frame the text well in the camera. I can see the text through the screen. I take a picture making sure that the camera is not moving at that time. But if I'm using the system without sight to try to find some text somewhere, then it is likely that if there is text at all in the picture, it is not going to be well framed, and it is likely that the picture might be blurry because maybe I was moving the camera while looking for the text. So this is an example in which we discovered that your typical OCR trained with typical data does not work well. So we had to retrain that from images that have been taken by real users. So this is just an example. So I'm curious to hear from you guys, because your products have been designed exactly for a particular type of community. How do you avoid the risk of bias in your systems? And I would say maybe you can start again from Patrick, and we go this way.
Yeah, this is actually, so in my opinion, bias in these machine learned systems is probably one of the most important issues that's coming up. As we see machine learning and AI becoming more and more adopted, this could take certain disenfranchised groups and further magnify that problem. These machine learned systems are only as good as the training data, which are these sample images or audio snippets. They're only as good as that data that's provided. There also, I think, is just some unconscious bias that could be naturally inherent in most people, and that could show through in the training data that's being collected and used, and then further reflect that bias within these systems. At Google, we have new teams that have been formed, actually ethical AI groups that we're building to look at these issues, to create specialized sample data sets and so on and so forth. And as Roberto alluded to at the beginning, initially when we've been doing research on, for instance, image recognition, image classification systems for blind users, some of the initial thought is to take the existing kind of models we have and reuse those. And we do see a lot of issues with that. For instance, a lot of these models for detecting items and images are trained on kind of web-based pictures, because that's what we have a lot of, right? We have tons of photos on the internet that are all tagged, what we call annotated, with examples of what's in those photos, and then those are used to build a model, and we say, hey, let's use that same model for a use case that supports blind and low vision users. These images, they're perfectly framed, right? The lighting's perfect, there's no blur, it's nice crisp images, and that doesn't reflect the reality of how someone with a vision impairment or who's blind might take a photo. So the performance is actually going to be subpar and not reflect kind of what they need. And so providing these sample data sets, as I mentioned, is super important, not only to prevent bias, but also just to provide tools that are realistic and reasonable and work well. So this is an area, I know at Google we have lots and lots of work going on. It's super important, and I do think it's going to be one of the more foundational challenges that we tackle in the AI community as we see prevalence of these systems rolling out more and more.
Well, I think Patrick, you nailed it. Getting the information that comes from real users or from the user's point of view is crucial when we build these models and we develop algorithms that power our devices. I know that in OrCams, I'll give you an example, and I don't work in R&D, I work in sales, but so take it with a little grain of salt. But the stories that I hear from our R&D, for example, we were trying to optimize how OrCam has OCR engine in it, in addition to other features. But for example, we're looking at optimizing how to help blind people and low vision people read street signs. And at first it didn't work, because exactly for the same reasons, the images that we used were web-based. We were asked to just go whenever we travel and take as many pictures of street signs as we can. Our employees, some of us are blind, some of us are fully sighted, some of us are low vision. But take actual pictures of those signs in different lighting conditions. Sometimes when the sky is bright and the sign looks dark. Sometimes when it's dark outside and both the sky and the sign is dark, and provide some of that feedback. As a result, our street sign recognition has improved significantly. We have done the same thing with facial recognition, for example. Our development team is based in Israel, and there aren't as many ethnic diversity as we have, for example, here in California. So when we launched our facial recognition, it didn't work for certain ethnic groups. Not because we were trying to be racist or trying to be bad, we just didn't test it on all of the ethnicities that we should have. We realized it very quickly and fixed the issue, but we learned from that. That was a great learning experience. We learned from that you really have to test based on who your target market is, as opposed to what's available nearby. Whether it's the ethnicity or the web images, whatever that may be, or the street signs in Israel, we have to look at them across the globe in the countries that we work with.
Yeah, I will add that it's also for that reason that it's very, 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 very important that we have this support from communities in order to get this data to make these systems smarter. But there's also other factors, like you said, light conditions, who's holding the camera, and even the hardware itself of the device. It also changes, and technology keeps improving over time, and so you have devices with better camera settings than the other ones. Some that have this smart focus kind of enhancements on the hardware. So all of this plays. So this is something that I believe that over time is going to get better as our camera. Now we have like 4 or 5 cameras on most recent smartphones, so they have a lot of these features to adjust the image and get better images and wider images. So hopefully, as this technology becomes better, we can also have better inputs from all types of users.
You guys know what you're talking about, huh? Very good. All right, great answer. So I'm going to go straight to the next and probably last question, because I see that we're getting closer to the end time, and I want to let people also participate here. And so I will make it kind of short here. So AI is great. We love it. Fantastic. Things work. But we need to be a little bit careful, because things work 99.99% of the time, and maybe there will be that time when it doesn't work. We don't want to generate false expectations, and we don't want to generate dependence that could be dangerous. Of course, people who work in autonomous vehicles know that very well, and that might be the reason why we keep postponing the time when we're going to jump into autonomous cars. If I have an app that tells a blind person, hey, now it's safe to cross, how much can you trust that app? That might be the best AI. But you do not want to become completely dependent on that. And here I will cite Stacy from the Vista Center in Santa Cruz. AI can enhance your skills, but cannot be your skills. So, how can we make sure that people understand the limitations? That's not easy, because sometimes, as we design the system, we do not understand the limitations because there might be an edge case that, as designers, we did not foresee that happens. So I want to hear your comments. I'm going to start with Marco. By the way, I want to share my admiration for Marco. He confessed to me that he's 29 years old and that he started his company in Mexico already 5 years old. So 5 years ago you were 24. Wow. And you already show a lot of experience and you have a product out. That's great. All right, Marco, go ahead and tell us what you think about this question.
Yeah, I think that's a great point. It's difficult though, because I mean you spend too much time trying to train your device to be as smart as possible, and then you tend to forget that there's a smarter person than your device using that product. So I think it's very important as a designer that you always try to take into account that the technology looks to enhance and not to invalidate the capabilities of the user. This is harder to do than saying, but I think it's very important because if you focus just on your product and making it as smart as possible, you're always going to miss an edge case, as you said. And on the other hand, I think it's also good to start thinking on not just the artificial intelligence, but also human intelligence. So there's not too much, there's a few interesting companies these days that are being powered by humans themselves. So I think it's also a great alternative, not just because human brain is awesome, but also because the human heart is awesome. And there's a lot of people out there willing to help, to assist, to train. So maybe if technology can use all of this as part of their product and focus on empowering the user, I think there could be great products that can come out of this.
When we use technology to help us in daily living, we're entering a relationship. So between you and that piece of technology or several pieces of technology, whether it's an app or device or something else, and it becomes a relationship. As a relationship, it's not 1 + 1, it creates something new. So when we work with the devices, we need to rely on our common sense, where it's safe to use the device and where it's not. And also, like Marco said, you know, we are humans, and at this point in the evolution of technology, we're probably smarter in some ways than the technology could be. So it's important to really figure out when it is that you can trust the technology and when it is that you can't. We'll bring another example from Orcam. When we released our first device, version 4, in 2014, I was blown away because I've never seen any assistive technology. I didn't come from the field. But one of the things that Orcam could do, it could tell you whether it was a green light or red light, whether you can cross the traffic or not. The first time I saw the device and my colleagues did, we said, please take it away. Why? It worked really well if you pointed at the right traffic sign. But what happened if you crossed the road where there were 2 traffic signs? There is no way for a person who's blind or severely vision impaired to know whether you're pointing at the traffic light that's closer to you or the one that's on the other side of the street. And then it could be potentially in danger. Obviously, our engineers were excited by the fact that they could design the technology that could identify traffic signs, but was it safe? It wasn't. It was in a demo device, so nobody got hurt, luckily, and we were testing it and looking at it. But you know, at some point, you have to say, yes, even if we can develop some piece of technology or particular feature, whether it's really safe for people to use, and if there's a potential to hurt one person, just one person, maybe it shouldn't be out there. So I think that was a really important takeaway from our own experience.
Yeah, I think the first kind of quote really kind of strikes true, where AI shouldn't be a replacement for certain skills you have. They should augment them, improve them, but not totally be used to kind of take them away as an alternative. So on my team at Google, one thing we've done research on